Hello gentlemen, this is Showman with Oil and Gas Field Quality Control. Sour service is very popular in oil and gas field and there are certain special requirements. Today I will concentrate about the material. For sour service we need NACE compliant material. Why it is so important in the oil and gas field we will discuss today. And we will also discuss what is PREN, pitting resistance equivalent number. Let us start. NACE is an international standard, American standard you can say, MR0175 or ISO 15156. It is the rule book for engineers which metals can be safely used in sour service. MR0175 or ISO 15156 is included in the Senior Corrosion Technologist Guide because of its foundation of sour service material selection, ensuring technologists can recognize risks, prevent cracking failures and keep oil and gas operations safe and compliant. The standard is often called by two names, NACE MR0175 and ISO 15156. It was originally developed by NACE International in 1970s as NACE MR0175. Later, for global harmonization, it was adopted by ISO in 2003 as ISO 15156. Today, both names refer to the same requirement, which metals can be safely used in sour service. I will discuss 10 major points of NACE MR0175 or ISO 15156 that are enough to read, understand and apply in the oil and gas industry. Purpose. It defines requirement for metallic material in H2S containing or sour oil gas environment to prevent cracking and corrosion failures. Failure mechanisms. Control protects against sulfide stress cracking or SSC, hydrogen-induced cracking HIC, stress corrosion cracking SCC and other hydrogen-related failures. Applicable materials. Covers carbon steel, low alloy steel, martensitic stainless steel, duplex and super duplex steel, austenitic stainless steel and nickel base alloys. Hardness limit. It specifies maximum allowable hardness less than 22 HRC for many carbon or low alloy steel to reduce SSC susceptibility. Environmental limits. Set permissible ranges for H2S partial pressure, pH, temperature and chloride content where materials can be safely used. Material qualification. Materials must be qualified through testing or proven field service experience for sour environments before use. 7th point is heat treatment requirements. Defines mandatory heat treatment condition like BWHT, quenching and tempering to achieve safe hardness and microstructure. There are 3-part structure of ISO 15156. Part 1 is for the general principles. Part 2 is for carbon and low alloy steels. Part 3 is for stainless steels and nickel alloys. Mandatory for sour service project. Oil gas companies, EPC contractors and regulators often require compliance with MR0175 and ISO 15156 for design approval. It has global recognition known as NACE MR0175. It is historic and the new name is ISO 15156. Both refer to the same standard as I discussed already, widely accepted in oil and gas worldwide. Now let us go for this NACE MR0175 or ISO 15156 overview. If the alloy is 6 molybdenum which is 254,6HN, the conditions of the alloy, it needs solution annealed and cold drawn. Applicable NACE table is A11 and solution annealed the table is A8. Application instrument tubing, control line tubing and compression fittings. Maximum degree centigrade or Fahrenheit or maximum H2S partial pressure. There are no restrictions. For cautionary remarks, please refer to the standard itself. For solution annealed, the maximum temperature is 60, which is 140 degree Fahrenheit, and maximum H2S partial pressure is 100 kPa or 15 psi. So similarly, there are another anti-corrosive material which is 625, which is very common. We are also telling it in colloy. Annealed and cold drawn, the applicable NACE table is A14. Solution annealed or annealing table is A13. This can be used for any equipment or component. Alloy 2507 also applicable for any equipment or component. So there are conditions. You can hold the table and then you can see the requirement in detail. The brief scope of NACE MR0175 or ISO 15156, it describes the general principles and give requirements and recommendations for the selection and qualification of metallic materials for service in equipment used in oil and gas production and in natural gas sweetening plants in H2S-containing environments. As a supplement, it can be applied to help to avoid costly corrosion damage to the equipment itself. ANSI or NACE MR0175 or ISO 15156 addresses all mechanisms of cracking that can be caused by H2S, including sulfide stress cracking, stress corrosion cracking, hydrogen-induced cracking, stepwise cracking, stress-oriented hydrogen-induced cracking, soft zone cracking, and galvanically induced hydrogen stress cracking. So if you go for the table 1, you will find the list of equipment which can be covered here, and there are some permitted exclusions. Let me read some for you. For example, if you go for drilling, well construction and well servicing equipment, there are exclusions for equipment exposed only to drilling fluids and controlled composition, and drill bits, blowout preventer shear blades, drilling riser system, work strings, wear line and wear line equipments, surface and intermediate casing. So these are exclusions from the tests. Similarly, if you go for pipeline, my channel is for pipeline. So if you go for the flow line, gathering line, gas gathering, field facilities and field processing plants, here the exclusion is crude oil storage and handling facilities operating at a total absolute pressure below 0.45 MPa or 65. This is coming under permitted exclusion. If you continue with this table 1, there are water handling equipment and the exclusions are there. Natural gas treatment plants, there are no exclusions. For all the equipment above, components loaded only in compression are excluded. Now let us check what are the contents. Name of the standard suggests that these materials testing and requirement all described in these standards are to be used in H2S or hydrogen sulfide containing environment in oil and gas production. The petroleum, petrochemical and natural gas industries are included. Part 1 describes about general principle for selection of cracking resistance material. Part 2 is cracking resistance carbon and low alloy steels and the use of cast irons. Part 3 is cracking resistance CRA or corrosion resistance alloys and other alloys. This third edition, which is 2015 edition, cancels and replaces the second edition, which was in 2009, which has been technically revised to contain the following changes in scope and clause 5: replacement of the term conventional elastic design criteria by the term load control design methods, inclusion of improved guidance on the approach to the qualification of materials for the use with strain-based design methods. Let us see the index, what is discussed in part 1. 1, 2, 3, 4 are generally same for all the 3 parts, which is scope, normative references, terms and definitions, abbreviated terms. Section 5 describes about the general principle. 6 is evaluation and definition of service conditions to enable material selection. Section 7 is selection of material resistance to SSC, SCC in the presence of sulfides from existing lists and tables. Section 8 is about the qualification of material for H2S service. The 8.1 is material description and documentation, 8.2 qualification based upon field experience, 8.3 is qualification based upon laboratory testing. So you can stop the slide and then you can read in detail, and also you can go to the standard itself if you need particularly the description of the tests for each and every part. Index for part 2. Cracking resistance carbon and low alloy steel and the use of cast irons. Here also, in section 7 you can see the selection of SSC resistance steels using table number A2, where 7.1.1 is where the H2S concentration less than 0.03 kPa or 0.05 psi, where H2S is greater than equal to 0.3 kPa or 0.05 psi. Option 2 is selection of steel for specific sour service application or for ranges of sour service. Section 9 is marking, labeling and documentation, and there are 5 annexures which are normative. Annexure A for SST resistance carbon and low alloy steel, Annexure B for qualification of carbon and low alloy steel for H2S service by laboratory testing, Annexure C is determination of H2S partial pressure, Annexure D is recommendation for determining pH, and Annexure E for information that should be supplied for material purchasing. So there are each and every detail of corrosion resistance material, especially for H2H related environment in oil and gas field. Part 3, the index for part 3. Here section 6 is about the selection of corrosion resistance alloys and other alloys with respect to SSC, SCC or GHSC in hydrogen sulfide containing environment. Then section 7 is purchasing information and marking. Then there is also similar 5 annexures. And 6.3 is more precisely for corrosion resistance material, which is PREN. So we will discuss in detail of PREN, because this term we used to see in our material related documentations. So what is PREN? PREN actually basically pitting resistance equivalent number, which also in short we are telling FPREN. This PREN number developed to reflect and predict the pitting resistance of a CRA based, means corrosion resistance alloy based upon the proportion of the elements of chromium, molybdenum, nickel in the chemical composition of the alloy. For the purpose of determining conformance with the requirements of the part of ANSI or NACE MR0175, all FPREN limits specified in this part of ANSI and NACE MR0175 shall be considered absolute limits as defined in ASTM practice E29. With the absolute method, an observed value of calculated value is not to be rounded, but it is to be compared directly with the specified limiting volume. Conformance and non-conformance with the specification is based on this comparison. The FPREN calculation is based on actual composition, not nominal composition. Nominal composition is used for general classifications only. So how to decide a PREN number and why it is important? So let us have some point to remember. PREN number or FPREN shall be calculated with this formula: WCR plus 3.3 within bracket W molybdenum and 0.05 WW plus 16 WN, where WCR is the mass fraction of chromium in the alloy expressed as a percentage of mass fraction of total composition. W MO is the mass fraction of molybdenum, WW is the mass fraction of tungsten in the alloy, and WN is the mass fraction of nitrogen in the alloy, expressed as a percentage of mass fraction of the total composition. So there are several variations of PREN, all were developed to reflect and predict the pitting resistance of iron, nickel, chromium, molybdenum, corrosion resistance alloys in the presence of dissolved chloride and oxygen. Example, in seawater. Though useful, these indices are not directly indicative of corrosion resistance in H2S containing oil filled environment. If you just want to know simply, higher values of FPREN provides higher corrosion resistance. Higher FPREN number provide higher corrosion resistance. So if you see this table A24, for environmental and material limits for duplex stainless steel used for any equipment or component, you can see FPREN greater than equal to 30 but less than equal to 40, molybdenum greater than equal to 1.5%. The temperature maximum it can be used is 232 or 450 degree Fahrenheit, and then partial pressure of H2S it can withstand is maximum 10 kPa or 1.5 psi. Chloride content, pH and sulfur resistance, we can see the contents at the bottom. So any combination of chloride concentration and in situ pH occurring in production environments is acceptable. So the table will give you idea which PREN value will provide you how much resistance against the corrosion. So this PREN number is very much important for a material in corrosion environment, especially for H2S related environment in oil and gas production. The lecture was boring, but the standard is super important in our oil and gas field. So we must know the basics, not in detail. At least we know what is NACE MR0175. Hope you gain some knowledge. If you like the way of my teaching and if you want your friends to know about this, please share it so that they can subscribe and get the information whenever I am uploading some videos. Thank you. Signing off for today, Showman.